Okay, this is the 2019 AP Calculus practice exam, the official practice exam. And this will be number 6, and this is a really good problem. It covers a lot of different things. All of it could be on the 2020 test. And I don't think all of it will be, but you can definitely relearn a lot of things from this problem. So it says, consider the curve 2x squared plus 3y squared minus 4xy equals 36. It says, show that dy dx is 2y minus 2x over 3y minus 2x. So what we have to do is differentiate this curve with respect to x. So implicit differentiation. So we have 4x plus 6y dy dx. And then we have to do a product rule here. So I'm going to put it in parentheses. The first, 4x times the derivative of y dy dx plus the second, y times the derivative of 4x, which would be 4y. And the derivative of 36 is 0. Okay, so I'm going to put all the dy dx terms on the left, 6y dy dx minus 4x dy dx. And then I'll move the non-dy dx terms over to the right. So negative 4y would become positive 4y. That's right, negative 4y. Push it over to the right, it'll be 4y. And then this 4x would be minus 4x. So factoring out a dy dx, which you could skip this step, 6y minus 4x. And then dy dx is equal to 4y minus 4x over 6y minus 4x. Let's simplify that by factoring out a 2. So we would have 2y minus 2x over 3y minus 2x, which is the answer they want you to get to. Okay, so that's a great review. Okay, a great review. You can see you getting a problem like that. Okay, so I'm going to erase this part and we will continue on. So we need to, for the next part, we do need to use this. So I'm going to rewrite this up here. 2y minus 2x over 3y minus 2x. That'll give us the slope of the tangent line. Okay, so we'll just leave that up there and refer to that. Okay, part B says find the slope of the line tangent to the curve at each point on the curve where x is equal to 6. Okay, so we've got to figure out what is, when x is equal to 6, plug 6 in, what are the y values? And it could be more than 1. So just going back to this original equation, we've got 2 times 6 squared plus 3y squared minus 4 times 6 times y is equal to 36. All right, that's going to be 72. Remember, you have your calculator, plus 3y squared minus 24y is equal to 36. I'm going to bring that 36 over. We would have 3y squared minus 24y plus 36 is equal to 0. Let's factor out a 3. I'd have y squared minus 8y plus 12 is equal to 0. We'll factor that. So this is good practice. I think we're going to have a minus 6 minus 2. So y is going to be equal to 2 and 6 when x equals 6. All right, so at the point 6, 2, the slope is equal to, and then we have to plug into this equation, what we found in part A. So 2 times 2 minus 2 times 6 over 3 times 2 minus 2 times 6. So that's 4 minus 12, negative 8. 6 minus 12 over negative 6, which would be 4/3. So that's one answer. And then at 6, that's going to be 2 times 6 minus 2 times 6. Oh, that's going to be 0 over 3 times 6 minus 2 times 6, which is going to be 0 over 6. Okay, so not really any calculus there. Got to use your Algebra 2, your pre-cal, to remember how to factor and then plug into the answer from Part B. So that's an excellent problem, just in case they make you do that on the 2020 test. So I'm about to erase this, and let's look and see what to do for Part C. Okay, Part C says find the positive value of x where the curve has a vertical tangent line. Okay, so a vertical tangent line occurs, you wouldn't have to write this part out, where the denominator is equal to 0. So where 3y minus 2x is equal to 0. So we'd have 3y is equal to 2x, y is equal to 2/3 x. We need to do that because then we have to substitute into the original equation in order to figure out what is the y value, or what is the x value. So we're going to substitute that 2/3 x into our y values here. So I've got 2x squared plus 3 times 2/3 x all squared minus 4 times x times 2/3 x is equal to 36. So that's 2x squared plus 2/3 squared would be 4/9, right? So 3 times 4 is 12. So 12/9 x squared, which would be 4/3 x squared, minus 8/3 x squared is equal to 36. Let's do this in thirds. So 2, that'd be 6/3, right? So 6 plus 4 is 10, minus 8 is 2. So 2/3 x squared is equal to 36. You'll have your calculator. X squared is equal to 36 times 3. All right, that's 108 over 2 is 54. So x is going to be the square root of 54. So that is the x value where you would have a vertical tangent line, where the denominator here is equal to 0. And we had to solve and do a substitution. Solve for y, do a substitution, and get the x value. So yeah, that's a good problem. It's a problem that would be tough to get to on the actual test, tough to finish that out, but you know, it's doable if you have the time to do it. All right, and let's finish this test up with Part D. Okay, so we still have this equation, all right, and it says at time t equals 1, the value of x is 2, y is -2, dy dt is equal to 4. And we want to know what is dx dt. Well, in order to get dx dt, we have to take the derivative of this with respect to t. So this is kind of a related rates type problem without having to do all the word problem of it. We're just going to take the derivative and plug the numbers in. Okay, and so we're not going to need this anymore. Okay, so let's take that derivative. So we would have 4x dx dt plus 6y dy dt minus, okay, this is a product rule, so we've got to be careful. The first, 4x times the derivative of y, dy dt, plus the second, 4y times dx dt, all right, is equal to the derivative of 36 is 0. Let's get all of the dx dt's on the left. Okay, so we would have 4x dx dt minus, so this is a minus, so minus 4y dx dt is equal to minus 6y dy dt, because I took that positive and moved it over to the right, and then minus 4x dy dt, I'm going to have to make that a positive if I move it to the right. Now we got to plug these numbers in. So x is 2, 4 times 2 dx dt minus 4 times negative 2 dx dt is equal to negative 6. Y is negative 2. dy dt is 4 plus 4 times 2. I'm right here. 2 times 4. Goodness. So that's going to be 8 minus negative 8. That's 8 plus 8, 16 dx dt is equal to negative 24 times negative 2 is 48 plus 32. All right, so that's 80, right? So dx dt is 80 over 16, which is 5. Look at us go. That finishes the 2019 practice exam. Number 6, I think, is a really good problem. All right, it can remind you how to do implicit differentiation, remind you how to differentiate with respect to t. We even got into some factoring, some substitution, so a great problem overall. So I will talk to you next video.